Welcome. I am Bhagyashree. I'll be explaining the Databricks Hackathon submission on behalf of our team. We have built a project called ClimaCast. It is an AI powered weather intelligence solution designed for Singapore's dynamic temperature. In the tropical Singapore, early weather shifts can disrupt the city operations. So, our project tackles this by delivering accurate real time weather intelligence. Our team is called Climate Avengers and our team consists of 4 members. The data set looks like this. Here we have used the historical hourly data from 2017 till 2025 and the 9 months of forecasting. The key variables here include air temperature, rainfall, humidity, wind direction, and wind speed. To predict the trends, rainfall trend, humidity trend, wind direction, wind speed, and all these forecasts are included to forecast air temperature trend. So we forecast the air temperature. So to do this, we have used the profit FB profit model and the metrics like MAPE, mean absolute percentage error, and so on. So our dashboard here is built on the Databricks SQL with no Python dependency. So we have implemented advanced SQL based visuals like rows plots and vulnerability indices, etc. So let's take a quick look at our ClimaCast dashboard. Here it provides the climate insights and forecast for Singapore. So here we start with the historical climate metrics like maximum air temperature, wind speed, highest discomfort index, and so on. Moving down the dynamic temperature trend chart, this shows how actual temperature have varied from 2017 to 2025 with the forecast in extending to 2026. So we see a relatively stable trend historically, but the forecast suggests there is a cooling pattern towards 2026. Here, this is a heat discomfort map. It visualizes humidity and heat discomfort indices across the different districts. The yellow zones indicate higher discomfort. This is a wind direction analysis. This reveals that most wind blow from the north and northeast, which is critical for the urban planning, especially for ventilation corridors and placement of high-rise structures, etc. So the rainfall analysis. This chart on the it is forecasted. It compares the forecasted rainfall against the historical daily average. So this is supported by it. This marks the flood prone zones by visualizing the high rainfall areas, which is ideal. This will be ideal for the infrastructure resilience planning and so on. The microclimate alerts. This section provides localized temperature trends. Moving on to the vulnerability index. The This map shows how climate-related stress varies across Singapore, with the warmer colors indicating uh, higher vulnerability. Finally, this the last line chart tracks the trend of vulnerability index over the years for each region. So, in summary, this dashboard allows us to not only track and forecast climate metrics, but it also identify localized climate stress zones, which is smarter policies, which is used to bring smarter policies and inventions across the Singapore. So the users can interact with the dashboard or also ask Genie, where is the rain likely in the next 3 days, or what are the unique cities, all these, anyone. So the Genie workspace integrates seamlessly and it answers the complex queries like queries and like this, and it also directly shows the relevant visuals if required. So our project ClimaCast, it runs directly on the Databricks workspace and supports integration with Power BI, Tableau, Looker, and it is accessible across the devices for planners, operations teams, and disaster responsive units. Thank you for watching. Visit our GitHub or dashboard to explore ClimaCast further.